Right, this is a sliding filament mechanism, and the project is done by Mark, Katie, Amanda, and
Step.
Stefan.
The action potentials arrive at the snapping
As
knob.
the action potential arrives, calcium membrane channels open up, allowing calcium to enter. Calcium causes the synaptic vesicles to fuse with the membrane of the cell. Vesicle, there is a chemical known as acetylcholine.
Acetylcholine, through exocytosis, is released in the synaptic cleft and then binds to the acetylcholine receptors. Acetylcholine binds the receptors, sodium-potassium channels open up, allowing sodium into the cell. This sodium initiates an action potential in the sarcolemma. And then the acetylcholinase pumps the acetylcholine back into the synaptic knob. The action potential travels down the T tubules in the sarcoplasmic reticulum, where it releases calcium from the terminal cisternae, where it was stored by calsequestrin, and then this calcium enters the sarcoplasm. Sarcoplasm is the fluid in the sarcomere, which extends from Z disc to Z disc. Within the sarcomere are mitochondria and groups of muscle fibers called fascicles. From the muscle fibers we get myofibril, which are made up of thick and thin filaments. The sarcomere also contains an I band, which is a light region, and an A band, which is a dark region. There is also an H band where the thick filaments attach. The filaments are made up of actin, troponin, and tropomyosin. The calcium flows over these thin filaments and binds to the troponin, pulling tropomyosin off the active site of the actin. The head is the thick filament, and this high-energy myosin head leaps to bind onto the exposed active site, forming a crossbreak. The myosin head pivots to the low-energy state, releasing ADP and moving the thin filaments over the thick filaments. This creates the power stroke. ATP then binds to the myosin head, causing the head to break free from the active site of the actin. Calcium is then pumped back into the sarcoplasmic reticulum and attached to calsequestrin, allowing tropomyosin to once again cover the active site, resulting in the relaxation of muscle.